Okay, so today we're going to move away from the exponents, or at least the general laws of exponents, and look at scientific notation. Some of you have used scientific notation in science, or you've read it in your science books because it deals with stars and mostly stars in science. Measuring distances. So we use it to measure things that are really big, and or to at least notate it, the notation part, and also things that are really small. So it's used both ways. So when a number is written as the product, that means multiply, of a factor and an integer, power of 10, you'll see this power of 10 thing, the factor must be greater than or equal to 1 and less than 10. That's a lot of words, so I'm going to put it in symbols for you as well. So the symbols would be a times 10. That's not an x, but it's a times. A times 10 to the n, where a is either greater than or equal to 1 or less than 10. And n is an integer. N can be any number, except we don't normally put a 0 there. And an example would be that. My salary, $425 million. Yeah.
No, it's not. Wait, is it? So that means $1 million. No, I mean, that's over here.
Okay, so we have this example of 425 million. And when we write this in scientific notation, it's going to look like this. 4.25 times 10 to the 8th. Raise your hand if you've seen some sort of notation like this before. Probably in a science book. I think you do this a little bit in elementary school, but not very much. And you didn't do anything like this in 7th grade. So don't feel bad if you haven't seen it lately anyway. Okay, so the first part we're going to look at is it'll say write each number in standard form. Here's an example of what it looks like to write it in standard form. We're going from scientific notation to standard. Some of you could probably see what I did there. But there's a 4 right here. and I go from the decimal place, if this is a positive number right here, positive 4, and I move it starting here, and I go 4 places to the right. And you don't need to write a decimal there, but that would be your new decimal. So positive 4 means I start at the decimal point and move 4 places to the right. So this 5.3 times 10 to the 4th was actually 53,400. Example 2, now I have a negative exponent. So 3.27 times 10 to the negative 3 equals 0.00327. So I go to the place where the original decimal point was, which is between 3 and 2. And now I'm going to go to the left 3 places. So positive is right, negative is left. And just like the number line, positive numbers go to the right and the negative numbers go to the left. So that's how you remember. Which direction are you moving? Okay. So that's writing it in standard form. Other times they'll say write each number in scientific notation. I abbreviated, so hopefully that makes sense. Write each number in scientific notation. So now we're going to go the other way. We're going to have a decimal or a big number and have to put this into the scientific notation form. So example 3, I have this number. This was my last year's salary. $3,725,000. Okay, it's not dollars, but fine. $3,725,000. So I start at the end, which is where there'd be an imaginary decimal point, right? And I need to make that point go all the way between the first 2 numbers. See on example 1 and 2, it's between those first 2 numbers. So I start counting. 1, 2, 3, 4, 5, 6. And that's how I get the 3.725 times 10 to the 6. So we don't write the zeros anymore. So if you have a big number here, greater than 1, you're going to have a positive exponent attached to your 10. Example 4, here's a small number. There's a decimal there. 0.000316. So I'm going to move this way. 1, 2, 3, 4. Because that would be the point between the first 2 numbers, the 3 and the 1. So I have 3.16 times 10, and make sure you put the negative with your exponent. This is an error people make, is they forget to put the negative. So numbers greater than 1, you're going to have a positive exponent. Numbers less than 1, you're going to have a negative exponent. Is there anyone that can raise their hand and tell me why we put the times 10 thing? Why times 10? Yeah.
Because 10 is the easiest to multiply.
It's pretty easy, you're right, but anyone see what happened when I did that? When I multiplied times 10? Yeah.
The decimal will move over one place.
The decimal does move over when you do that. So the 10 tells us, oh, we're going to move this, right? We're going to change the value, but not really, because we're going to add the exponent for however many places we move. Okay? So it'd be like if you took the 3 million, that number, and multiplied by 10, you're going to get like a really big number, extra zeros. Okay? But you're right, the 10 does make it simpler. Yes?
How do you know how many times to move what?
So if you're going this way, from scientific notation to standard, then you count. You already have the numbers, right? But if you're going this way, you just start at wherever your decimal point would be, which, you know, at the end of a number, it's there.
Yeah.
And you count backwards. If you have a decimal point, then you can just count right. And this is 6, and this one is 4.
Okay.
But just don't forget the negative. Question?
You said for 3 and 4 that if it's a really big number, you know, just bigger than 1.
Mm-hmm. Any number bigger than 1, positive.
But for example, example 2 is bigger than 1, but it's
This
negative.
number is less than 1. 0.00. I mean this number in standard form. Okay? All right, awesome. So we're going to do some practice in your book.